Diving into the world of simulations, and there's theoretical probability we'll learn about, which is the ratio of the number of favorable outcomes to the total number of outcomes. And oftentimes we use an experiment or experimental probability. In other words, we're actually conducting an experiment. And let's just get over to the idea of probability to begin with. Let's say that we could say then it is the ratio of the number of favorable outcomes over the total number of outcomes. All right, let's attack our little problem here. Students were asked how they travel to school each morning, so we're doing a survey. And it says, find the experimental probability of randomly selecting a student who does not ride in a car or a bus. Well, the first thing I really want to do is find out how many total outcomes or how many students did we actually talk to. And I see this frequency side of this table. And if I add all that up, that would be the total number of outcomes. So let's see. Well, 3 and 17 is 20. 20 and 21 is 41 plus 6. Then you have to use a calculator, so that's 47. So there's a total of 47 students asked. Now, of that group, 3 said they rode a bike, 21 said they rode a bus, 17 a car, and 6 walked. It says find the experimental probability of those a student who does not ride in a car or a bus. So does not ride in a car or a bus. So we want to exclude that and that. And then that leaves us with just a bike or a walk. And that's 3 rode a bike and 6 walked. So 3 plus 6 is 9. So in this case, our experimental probability is 9 out of 47. Or, let's calculate a percentage on that. 9 divided by 47, 19. I'm going to round that to the nearest full percent, or approximately 19%. So, when we're looking at probabilities, we got a ratio, number of favorable when we're doing simulations, number of favorable outcomes to the total number of outcomes. Next, we're going to actually design a simulation.